All right. Good afternoon, everyone, and thank you so much for joining me today. So, as the title says, I'm going to talk about bringing structure to your event-driven systems or streams and how you can manage them in practice. And basically, that's what I'm going to talk about today. A little bit about myself. So, I work as a director in developer relations at WSO2. So I have been in the open source middleware space for about 15 years now. And I have my background spans software engineering, solutions architecture, a little bit of technology evangelism, and also now in developer relations and advocacy. So my main focus areas have been on API management, integration, and identity and access management. So yeah, that's about me, and let's dive into the presentation. So first, let's start a bit about the async API management gap, right? So if you talk about REST APIs, they have had 15 plus years. They have been here like for the past 15 plus years. And it started off as a mere developer curiosity, but now it has evolved into, you can say the backbone of digital ecosystems, right? So it's backed by the Open API specification, and it's reinforced, with mature tools. You can have established, you have good governance practices around it, developer onboarding and all of that. You have standardized practices. So what happened later was after, organizations started going behind the responsiveness and, real-time responsiveness of async APIs. So they started to embrace technologies, async technologies like Kafka, MQTT, WebSockets, and so on. Obviously, they gave so much more than what REST alone could offer. So then people wanted to embrace these technologies and, for real-time experience. So if you take some examples, you can take, let's say a logistics company might have want trucks to basically update their location continuously, or you can have a stock trading platform that must basically get stock updates or market updates in milliseconds, right? So you don't want to basically poll for this information. You want the updates then and there, right? And then you may have a healthcare application that will want patient data updated as and when they change. So basically, you need all of that. So asynchronous APIs are basically really cool, but there is definitely a management gap, right? Like in terms of managing them. So the tooling around them was not mature. So this is a while back, right? So ungoverned async APIs are brittle, insecure, and unscalable. So let's just talk a little bit about the disconnect in terms of if you're talking about it using an analogy, you can talk about REST as being a highway with clear rules, and it's pretty, straightforward, and everything's pretty much done in an orderly fashion. Whereas async APIs could have basically be compared to the back roads. You can take the back road and go faster, or maybe, it's chaotic, and basically there are no clear rules, no guardrails, right? So if you take REST APIs, you have so this is not in recent times. I'm just talking about, let's say, like a few years ago, it was just Open API out there. And you had standardized onboarding, clear authentication practices, developer portals, and established governance for REST APIs. Whereas with async APIs, you just had ad hoc documentation, and people had to basically go and figure out what they actually did, what the Kafka topics actually meant, what the payload was like, and things like that. So basically, they were documented in like maybe Slack documents or maybe wikis, and then people had to just go and find the developer and figure out how and what do these topics contain, what kind of topics are there, and things like that. So obviously some topics were not secured and things like that. So REST APIs, you can say it's a smooth regulated highway, whereas async APIs are unstructured backroads, fast but chaotic, right? So let's dive into these three real world pain points. So I just want to focus on these three today. So if you look at onboarding developers to async APIs has been like difficult, right? So there was no clear documentation. So like I said earlier, they needed to find out how these topics worked or what kind of security is supposed to be applied and things like that. So there was no proper self-service. So that because of that, it took a lot of time, not weeks, like weeks and not minutes. And there are security gaps, right? So event streams lack standardized security. Some teams, so it was all fragmented. Some teams may secure the APIs using API tokens, whereas someone else would have been securing it another way. So maybe OAuth2 or custom team solutions basically create fragmentation and vulnerabilities. And then so if you talk about the visibility aspect, some companies may have hundreds or maybe tens or hundreds of Kafka topics lying around. So people don't really know what they do or whether, how to discover them basically and how to reuse them. So because of that, there was no way to track them or trace consumption and see what the dependencies were. So these were real world pain points. So what's the fix? The fix was to treat these event streams as products, right? So where you think of these as basically products and not pipes, right? Like if you take a Kafka event, or basically you think of it as a business capability managed with clear product life cycles, just how you would treat a REST API. So you have to think about the business alignment aspect and figure out so not just name an event like using technical terms, but just say something like order created event and things like that. And you need to establish clear ownership, SLAs, and lifecycle management for these products similar to REST APIs, right? So what enabled this? So AsyncAPI came up, and it was just like what OpenAPI was for REST, AsyncAPI was for asynchronous APIs. So it helps standardized event-driven architectures, especially in terms of documenting them and basically creating the tooling infrastructure for asynchronous APIs. So you can design it's a design spec for event protocols like Kafka, MQTT, and WebSockets. So here I've just used an old spec. So this is 2.6, but obviously you can use AsyncAPI 3 now and basically make use of all the functionalities that now it provides, right? So with using the AsyncAPI, you can document events and schemas and then generate code for consumers and producers. And you can use AsyncAPI specification for testing and mocking. Right, so AsyncAPI in practice, so the success stories would be like initially developers would be like, okay, we don't want to waste time writing another spec because that's something that they treated as an overhead because it's not something they wanted to do initially, but they obviously realized that this is something that is going to save time for them in the long run, right? So with AsyncAPI, you come up with consistent naming, schema reuse, and automated testing, and it became standard with spec first design. And then obviously it boosted productivity because even though you write the spec, that means you use the spec as a single source of truth to generate docs, SDKs, and basically validation pipelines and things like that, saving weeks of development time. And then there's clear visibility because when you look at the AsyncAPI spec, people understood what the stream or what what the APIs were supposed to be doing, and what the payload was, what kind of endpoints were there, and things like that. So it was like creating a playbook and not just messy post-it notes, right? All right, so with AsyncAPI, we enabled contract first development. So especially in greenfield development, where you maybe if you don't have your backend Kafka streams or backend WebSocket endpoints, you can come up with your specification, or you can define how those APIs should be, and then come up with the contract first, and then you can enforce consistency and best practices for both the consumers of these APIs as well as the producers, right? So you enforce consistency and best practices, and it's easier maintenance with a single source of truth, because if anything changes, you basically have a single source of truth to depend on those changes, for those changes. And then there's faster onboarding and improved collaboration, because obviously everything's documented and you have everything there. And then there's parallel development. You don't have to wait for the back end to be ready for you to write the front end. And then there's clear consumer expectations, because obviously you've documented everything, what the expectations should be. And therefore, spec first transforms event systems from reactive to proactive design. Okay, so now that we spoke about a little bit of, bringing structure to asynchronous APIs with async API specification, let's see how we can manage these streams in practice with some API management tools. So I'm going to use WSO2 API Manager as the API management tool here and show you how it's done. I'm also going to cover a little bit of what Ankit covered earlier, because he also showed how you can bridge backend streams and front-end applications, do protocol bridging and things like that. So I will also explain a little bit about that. So if you take a look at this, if a company or if an organization wants to come up with an event-driven architecture, so here you will see that maybe there is a kitchen service, a delivery service, all async APIs, or basically they want to fire the events to Kafka and basically make those available, right? And then obviously there are front-end mobile applications and front-end web applications that want to consume these events, right? But then when you start building this, the team may come to a standstill and wonder, okay, so there's Kafka, how do I expose the Kafka protocol to the front-end application? So do I do the security aspect of it? Basically, who gets to subscribe to these events? Whom do I allow to access these events? Then do I let any kind of application overwhelm my Kafka streams? Then what about transforming the Kafka streams to, say, a web-friendly protocol? So how do I do that? So does this team that is basically focusing on the business aspect, or are you going to let them also figure out this middle layer, right? So why not let the developers focus on the business logic and let an API management tool handle the rest, right? So you can use a tool like the WSO2 API Manager or any other API management tool to basically do protocol bridging, apply security and rate limiting for your asynchronous APIs. Okay, so let's just talk a little bit about what we can cover under governing async APIs. So API management tools can play the designated role with event-driven APIs too. So if you take REST APIs, it's pretty standardized. You have, people can document their APIs. The developers of these APIs can design, apply governance rules, test and deploy proxies for event-driven APIs in API gateways, and publish information about those APIs in developer portals, right? And then at the same time, you also need to manage the life cycle of those APIs. You need to monitor them and also document these APIs and apply security, and maybe have community forums around them, and and see what the consumption is like. So this is the governance aspect and the API lifecycle management. Right, so even though most organizations have event processing infrastructure, many don't have the capabilities to design, develop, test, and manage them. Right, so I have some screenshots. I don't have a demo for you today, but I can just explain what happens here. So if you have, let's say, a WebSocket API or a webhook API or any other kind of streaming API, which is already existing, you can, or it doesn't have to exist, you can assume that you're creating an API proxy for it. You can do it like this. So this is a general view. You can create a REST API or a SOAP API. So in this case, we are interested in creating a streaming API. So if you already have an AsyncAPI specification for it, you can import that file, or else you can create a proxy from scratch, right? So after you configure the proxy, you basically get this API proxy configuration information. Like, so here you can see it's still in the develop state. You can see the endpoint, the production endpoint is obviously a WebSocket endpoint. And you can see the topics that are defined for this WebSocket, right? And you can see that the security we've applied here is OAuth 2. And so you can use the UI of the API manager to come up with the spec as well, and then create the API proxy for it, right? So in async APIs, you get topics instead of REST resources. So you can see these separate topics listed here, and if you want to apply security or anything else like throttling for these topics independently, then you can do that as well, right? And here you can see the resulting async API if you went ahead and created this from scratch, or you could, or this could be the async API document that you imported, and you get a resulting API proxy. And with that, you can manage the lifecycle of the API as well. So you can create the API, and it could be only in the created state. Or else it could be, you can publish it to the developer portal. So that means that it's made available to consumers. And if there's let's say, a revision or an update to this API, then you can deprecate the API. And if you need to retire the API, then you can basically manage the lifecycle of the API as well, right? Okay, so let's talk a little bit about the proxying aspect that happens within the gateway. So API gateways can be used to proxy existing asynchronous APIs to apply runtime governance such as security, throttling, and monitoring, right? So API proxies are what you create to back or to front your existing APIs. And so the API developers can design and test and deploy these proxies for these event-driven APIs in the API gateway, for the API gateway, using using this view, right? And then once they're deployed in the API gateway, once these API proxies are deployed in the API gateway, you can apply authentication, rate limiting, monitoring, and analytics to your backend event-driven APIs. So let's take an example here. So if you take a WebSocket API, it could be this chat server, right, which is hosted on this URL, right? So if you create an API proxy for it, what happens is in the API manager, you create an API proxy which is going to be available at this on this URL, right? So the web application will obviously want to communicate to this, or basically add an event or subscribe to an event in this notifications channel. So what it does is it first has to talk to the API proxy. So the only way it can talk to this backend channel is through the API proxy. So basically there's WebSocket communication between the web app and the API proxy, and the API proxy, depending on how your API is configured, will apply throttling, security, and also will monitor that fire events to monitor that consumption, and then finally communicate with the backend channel, right? So you can also do URL mapping and things like that. And that's pretty much how proxying would work in an asynchronous API proxy. So a little bit about security and rate limiting. So when you during runtime, security and rate limiting is applied if it is configured. So they're secured and rate limited using the same methods as REST APIs. So you're looking at consistent security standards like OAuth tokens and scopes, API keys for authentication, and then consumer quotas can be applied where you set limits for resource allocation. So let's take a look at how that's also configured. So it's pretty simple. So during the design, you can basically designing of the API, you can configure these. You can configure application level security, and also you can configure which key manager you're using. Maybe you have multiple IAM systems, and then you can basically select them and decide on how the security works, right? And then you can also do rate limiting where you maybe can be 10,000 events per minute and things like that. And you can also add business plans for your at the application level, where you can specify things like, okay, allow 50,000 events per day or 25,000 events per day, and so on. And you can manage the subscriptions. Right. So the final aspect I want to touch on is the developer portals aspect. So this is where you publish the async APIs alongside REST in the same portal. So this means your consumers can basically discover all of your APIs in one single place, right? So you're looking at unified discovery. So everything's in one location. So that means better developer experience for these consumers. And now a real world example would be like a retail company can publish an order service REST API and an order event stream API. So a consumer might just go and decide for himself whether he wants to get basically send a request and get the order details, or whether he wants to be notified of all these order events, right? So this productization transforms event APIs into first-class citizens with proper descriptions, usage policies, and structured onboarding. Okay, so this is what it would look like in the portal. So you can have all your APIs displayed in one place, and through this single place you can go and check the documentation, generate SDKs, and basically get information about any kind of API. So if it's an event API, you go to the API and figure out what the topics are, and basically go through the documentation, figure out what the endpoints are, what the security schemes are, and basically understand the API offerings that you have, right? So unify REST and async APIs is great because that means there's shared governance, there's consistent policies, lifecycle versioning, naming for REST and async APIs, and then like I said, there's protocol agnostic discovery. So developers, they prioritize efficient data discovery. They don't care about the API protocol. They basically see, okay, this is pretty much what I want, and this is supported, and I will use it, right? And then full productization. That's where APIs are treated as products with owners, service license agreements, and usage metrics. So because of that, there's reduced duplication. There's single governance, eliminated redundant efforts across teams and protocols, and there's unified metrics. So platform teams gain full visibility across all API types. So what I covered was basically just the core capabilities, some of the core capabilities of what an API management platform can offer. So in the API management control plane, as you can see, we discussed how you can apply API security to your backend APIs, and how you can, basically design these proxies using API design and development tools, how you can govern the life cycle of your APIs. And we talked about the API dev portal, and there's also API mediation and policy management. So with API mediation, you have protocol mediation. Basically, that's where you bridge different protocols, and then you can also extend those capabilities to things like ingress and egress governance, especially if you want to like govern LLM usage and things like that. So all of these capabilities can be made available to you through an API management platform, and during runtime, the API gateway will basically enforce the governance aspects, and basically it can be any kind of API, REST API, SOAP, GraphQL, and also your asynchronous APIs, all governed by these rules. So summary and key takeaways are these. So async APIs also need REST-like governance, that same rigor. So use async API the specification to provide the structure and basically document your async APIs, and with that have unified governance to speed up adoption and reduce complexity, right? And what you can do is make async APIs discoverable in developer portals and make them known, secure them consistently and apply rate limiting, and govern under the same lifecycle policies as REST APIs. Okay, so to wrap up, async adoption will accelerate. So it's up to you to figure out whether you're going to treat your asynchronous APIs as a highway, or if you want to leave them as a dirt trail, right? So that's it. I don't know if I'm over time, so I don't know if, if there's time for questions, but if I'm allowed, I can take a few.
Anybody who has a question? While we are taking questions, the next speaker should prepare.
Okay.
Thank you. So actually, this is a product question, if I might, about WSO2.
Yeah.
Is it going to API gateway, I mean the proxying part, and asynchronous APIs? If you combine those, does it replace products like Confluent, Kafka, or say RabbitMQ, or
No.
does it augment that?
It basically it's basically going to augment it. Actually, it's going to support whatever is there, and it's going to front it by enforcing the governance aspect to these. So basically, you're going to access these streams through a proxy, which makes
Understood.
sure that you apply rules, and also make sure that it's seamless, and that there's security and rate limiting applied, so that you have full control on who accesses your streams.
Thank you.
All right.